Hi everyone, let's talk about real-world applications with solving quadratics by graphing, aka word problems. So what we're going to do, just like we did last time, is read through the problem, highlight key information, and that'll help us solve the problem. So starting with number 1, trajectories. David threw a baseball into the air. The function of the height of the baseball in feet is this function right here, where t represents the time, that's key information, in seconds after the ball was thrown. Use this graph of the function to determine how long it took, so what we're looking for, how long it took for the ball to fall back to the ground. So our goal is to find how long it took to get from 0 to 5, all right, to get to those two spots. Now, if we're just looking at this logically, right, this is seconds, right? Our x-axis is seconds. So this is at 0 seconds. This is at 1 second. It was right here. At 2 seconds, it was up here. At 3 seconds, it was right here. At 4 seconds, it was right here. And then at 5 seconds, it hit the ground again. So really, we don't need to do any math to solve this problem. We just got to think about it logically. So it took from 0 to 5 seconds for the ball to get back down and to the ground. So our answer is just 5 seconds. So this problem just wants you to be able to read a graph and understand what you're seeing. All right, number 2, we're talking about bridges. In 1895, a brick arch railway bridge was built on North Avenue in Baltimore, Maryland. The arch is described by the equation h equals 9 minus 1 over 50 x squared, where h is the height in yards and x is the distance in yards from the center of the bridge. Graph the equation and describe to the nearest yard where the bridge touches the ground. So we're looking for the distance to the nearest yard where the bridge touches the ground, and the ground would be our x-axis. So first thing we want to do is graph our equation. All right, and we know our equation is h equals 9 minus 1 over 50 x squared. Now, if we wanted to write this so it looked more like a quadratic equation, right, we can just switch around. So it looked like negative 1 over 50 x squared plus 9. All right, that's the same equation as this. But now we've got our x squared plus 9 plus our constant. So it looks like it's more in the form ax squared plus bx plus c. All right, now how we want to graph this is just by using a table. So what we're going to do is we're going to make a table. All right, but we first have to figure out what value is going to go in the middle of our table, and we do that by finding our axis of symmetry. So we know the formula for axis of symmetry is negative b over 2a. So we don't have a b, so here our b is just 0, so negative 0 over 2 times negative 1 over 50. Now, it doesn't really matter what this equals because 0 divided by anything equals 0. So our axis of symmetry is 0. So now we make, we make our xy table and we put 0 in the middle. Then we want values smaller than 0 and greater than 0. So let's start with the values negative 10, negative 20, 10, and 20. All right, because we just want an idea of what this graph is going to look like. And we know our numbers are going to be a little bit on the bigger side. So when we plug 0 into our original function, right, we're going to get 0 squared times anything is 0 plus 9. So 0, 9 is our vertex. Then when we plug negative 10 in, we do that in our calculator, all right, and we're going to get 7. If we were to plug negative 20 in for x, we do this on our calculator, we're going to get 1. If we plug positive 10 in, we're also going to get 7. And if we plug positive 20 in, we're going to get 1. So what we want to do is we want to start by graphing these points on our graph. So we know our vertex is going to be 0, 9. So first things first, let's label our axes, right? So if we're labeling our axes here, let's go by tens in both directions. So 10, 20, 30, 40, 10, 20, 30, 40, negative 10, negative 20, negative 30, negative 40. All right, and we know our vertex is at 0, 9, so that's going to be our point right there. Now we know our other points. Let's see, we've got negative 10, 7, and negative 21. So negative 10, 7 would be right about there, and negative 21 would be right about there. And then positive 10, 7, positive 21. Now, our goal is to see where it touches the ground, right? So at 20, at negative 20 and positive 20, it's still 1 foot above the ground. So what we want to do is we want to plug in some more points and see what it looks like to the left of negative 20 and to the right of positive 20. So if we're plugging in some more points, let's say negative 22 and negative 21, and positive 21 and positive 22. All right, so these first two, negative 22 and negative 21, are just to the left of this point right here, right? We're talking about just to the left. And then positive 21 and positive 22 would be just to the right because we want to see if it touches the ground, if it crosses. So if we plug in negative 22 into our original function, do this in our calculator, we're going to get negative 0.68. And if we plug negative 21 into our calculator, we're going to get 0.18. If we plug positive 21 in, you guessed it, we get 0.18. And if we plug positive 22 in, we get negative 0.68. Now, what does this look like on our graph? So negative 22, negative 0.68 would be below ground, and we don't want that, right? Negative 21 would be just above ground, all right? And then the same on the other side for positive 21, and then positive 22. So what we're looking at here is, if we're zooming in on our graph, right, we know our quadratic goes like this. That's what our quadratic function looks like. So what we want, what our goal is here is to figure out where does it touch the ground. So between negative 21 and negative 22 is where it touches the ground on the left side. So we're going to the nearest yard, so we're going to say negative 21 because that's the closest we're going to get to 0. And then on the other side, it would be positive 21 because 0.18 is the closest we're going to get to 0. So distance from the center of the bridge, we know the center of the bridge is at 0, 9. And we want to describe where the bridge touches the ground. So it touches the ground 21 yards from the center of the bridge because it's at negative 21 and positive 21. So how we would describe this is we would say 21 yards from the center of the bridge. And that's where the bridge touches the ground on both sides. So it touches it at these 2 points, negative 21, 0, and 21, 0. So we put it in words, and we also put it in ordered pairs. All right, if you have any questions on this problem, or number 1, please feel free to raise your hand and ask. Otherwise, look to the board to see what to do next, and I hope that you have a great day.